Imagine a nuclear submarine in orbit. It sounds like something out of a sci-fi movie. But what if I told you it could survive for a few days? At least, you might be shocked by why it wouldn't last more than that. And it's not what you think. Stick around as we uncover the real science behind this outlandish idea. Now, let's start by thinking about pressure. Submarine hulls are incredibly strong. They're built to withstand the immense pressure of the deep ocean, where they deal with 50 to 80 times the pressure of the atmosphere. This means that in space, where there's no pressure at all, the submarine hull wouldn't burst or collapse. The submarine could easily handle the vacuum of space, and the atmosphere inside it would remain intact. So that's not the problem. The real issue, though, is something a little less obvious. That issue? Heat. A nuclear submarine, just like any other nuclear-powered vessel, has a reactor on board that produces a tremendous amount of heat. On Earth, this heat is no big deal, because seawater carries it away. But in space, there's no water to absorb and dissipate this heat. In fact, there's no medium at all to carry the heat away. So what happens when there's nowhere for the heat to go? The submarine would start getting really hot and fast. Think about this. The nuclear reactor on board a submarine is typically rated at around 200 megawatts of power. But not all of that energy is used to propel the submarine or power its systems. About half of that power, roughly 100 megawatts, is lost as heat. On a normal submarine, this heat is absorbed by the seawater, keeping the reactor and the whole vessel at a manageable temperature. But in space, without seawater to act as a heat sink, the heat would build up inside the submarine, making the entire vessel dangerously warm in no time. The heat would increase the temperature of the submarine by about half a degree Celsius every minute. That might not sound like much, but within an hour, the interior temperature could rise by over 30 degrees. That's enough to make the submarine uninhabitable for any crew inside. If the reactor can't get rid of its heat, it will eventually overheat. Without proper cooling, a nuclear reactor can suffer a meltdown, just like what happened in Chernobyl or Fukushima. But in this case, the reactor is in a tiny confined space, and there's no way to shut it down. The whole submarine would be at risk, catastrophic failure long before it ever had a chance to complete its mission. Now, let's talk about the other challenge. How to get the submarine back to Earth. After all, once it's in orbit, it needs a way to return. You might think that if the submarine had rockets, it could use those to slow down and re-enter Earth's atmosphere. But here's the catch. While a submarine does have rockets, they're not attached to the submarine. These rockets are part of the submarine's missile systems, like the Trident missiles carried by the Ohio-class submarines. And while it's a fun thought, launching these missiles backward wouldn't help much. Even if you somehow managed to aim them in the right direction, each missile would only change the submarine's speed by about 4 meters per second. That's nowhere near enough to deorbit. For comparison, to get back to Earth, you need a speed change of around 100 meters per second to start re-entry. So while 24 missiles might sound like it could work, they wouldn't have nearly enough power to get the submarine back to Earth. Without proper propulsion, the submarine is stuck in orbit, and there's no way to make it safely back. Let's say, just for fun, that the submarine somehow managed to start falling back toward Earth. What happens next? As the submarine re-enters the atmosphere, it would face the heat and friction of high-speed re-entry. But here's where things get really interesting. The submarine isn't designed for re-entry. It doesn't have the ablative tiles or the aerodynamics necessary to survive the intense heat and pressure. As a result, the submarine would likely begin to tumble uncontrollably, breaking apart in the atmosphere as it descends. Any debris that makes it through the atmosphere would be disintegrated by the extreme forces, and what's left would crash into the ground at a speed so fast it would be like a bullet hitting the Earth. Now, let's throw in one final hypothetical. Could anyone survive this disaster? Well, if you were in the submarine at the right moment, you might have a chance, but it's a long shot. You'd need to strap yourself into an acceleration couch to survive the insane deceleration during re-entry. And once the submarine breaks apart, you'd need to leap out of the wreckage, pull a parachute, and hope for the best. But even if you manage that, the odds of survival are still pretty slim. And here's one crucial tip. If you ever find yourself in this ridiculous situation, remember to disable the missile detonators. No one wants a submarine exploding in space or on Earth, because you forgot to do that. A nuclear submarine in orbit is a really bad idea. From the heat buildup inside, to the lack of propulsion, and the ultimate crash back to Earth, it's clear that a sub wouldn't last long in space. But that's the fun of these thought experiments. Imagining the impossible and learning a bit about the science behind it. If you enjoyed this wild scenario and want to hear more, hit that like button, subscribe for more fun deep dives into crazy ideas, and let me know in the comments, what impossible scenario should we explore next?